So the probability of occurrence of any events are determined with the help of mathematical calculations. When you toss a coin, you get either a head or a tail. So such kinds of events can be had in binomial distribution. So all 10 are defective means NCR equals P to the power of R into Q to the power of N minus R. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session on theoretical distributions, we will be having a discussion on the meaning of distribution and also the various types of distribution. So, distributions are normally based on certain assumptions, but every assumption basically follows certain mathematical calculations. So, we are familiar with distribution. So, what do you mean by distribution? So, we have studied about the frequency distribution table, or we can see in this what is distribution and what is the probability of occurrence of events. So, the probability of occurrence of any events are determined with the help of mathematical calculations. So, if we are conducting a survey, then the survey will have certain highest points and the lowest points, and all other the results, they will be falling in between. So, in this we will be having a study of the distribution. So, here in this, the first type of distribution is the binomial distribution. So, as the name itself suggests, it is a distribution which was developed by the mathematician. So, this theory was developed by the Swiss mathematician Bernoulli. So, binomial means two possibilities. So, as the name itself suggests, so these distributions are useful only when there are two possibilities. Either it is a success or a failure, or you reach the target or don't reach the target, and if it is a male or a female. So, in this way, this kind of a binomial distribution is useful only when there are two kinds of results. So, the binomial distribution explains the probability of success or failure of the events. Then, next, let us go into the characteristics of binomial distribution. So, what are the characteristics of this kind of a distribution? So, the alternative of success and failure. So, in case of binomial distribution, we can always say that the probability is 1 and the probability of success is P and the failure is Q. So, either you get a success or you get a failure. So, there are only two chances here and nothing will be there in between. So, the outcome of those events will be only two. For example, when you toss a coin, you will get either a head or a tail. So, there will be no other in between results. So, that is what we mean by this binomial distribution. So, alternative of success and failure. So, when you toss a coin, you get either a head or a tail. So, such kinds of events can be had in binomial distribution. And next one is the trial should be more than one. So, more than one trials we can have. The probability of success in each trial should be constant. So, whatever is there, so the probability of success in each trial should be constant, and all trials are dependent and identical. So, all trials should be dependent and identical. So, independent and identical. So, what do we mean by independent and identical? For example, take the example of tossing of a coin. So, whenever you toss a coin, so if all the coins are tossed at the same time, so each time the result will come, it will be independent of the tossing of the other coins, and then it will be always be identical. So, whenever you toss a coin, all the coins will be tossed in the same way and the trials should be identical. Then, next one is the formula for binomial distribution. So, n into a plus b whole to the power of n equals n into a to the power of n plus nc1 into a to the power of n minus 1 into b to the power of 1 plus nc2 into a to the power of minus 2 into b square up to b to the power of n. So, here the capital N stands for the number of events and the NC1, it will denote the number of trials. So, A is the probability of happening of the event and B is the probability of not happening of a event. So A is the success and B is the failure. Then fitting of a binomial distribution. As per the binomial distribution, the probability of 0, 1, 2, 3, 4 success would be obtained by the expansion of A plus B whole to the power of n, where the experiment is repeated for any number of times. Then the frequency of success would be NPR equals n into NCR, A to the power of R, B to the power of n minus R. So, where n is the number of times the experiment is repeated. So, number of times the experiment is repeated, that is denoted by capital N, and R is the expected frequency of success, N is the number of outcomes, A is the rate of success, B is the rate of failure. So, these are the various things we need to see when we make use of this formula for binomial distribution. Then let us look into the properties of binomial distribution. There are two outcomes in an experiment like success, failure, male, female, head or tail, hitting the target and not hitting the target. So in case of a binomial distribution, there are only two outcomes, that is success, failure, male, female, head or tail, and hitting the target and not hitting the target. The probability of occurrence of an event remains same throughout the experiment. So the occurrence of event will remain the same. The trials are independent of each other and experiments are conducted under identical conditions. So these are the four properties of binomial distribution. Then next, a fifth property is n is not very large. N is the number of trials are not large. So the number of trials should always be less than or equal to 30. Then mean of binomial distribution equals n into p. So mean is represented by this mu equals n into p. Then standard deviation of the binomial distribution equals, so we have this symbol here, this standard deviation symbol here, equals root of NPQ. The variance equals standard deviation or NPQ. The skewness equals B1 equals A minus B the whole square divided by NPQ, and kurtosis will be B2. That will be 3 plus 1 minus 6P by NPQ. Now, we'll go into the problems here. Find out NPQ when the mean of the binomial distribution is 192 and the standard deviation is 8. So, given, what is given? Mean equals n into p equals 192 and standard deviation equals 8. So, this is equal to root of NPQ equals 8. So, I have the root of NPQ. So, the standard deviation, the whole square will be 8 square. That will be equal to root of NPQ into root of NPQ equals NPQ. So, 64 equals NPQ. Now, since n into p is 192, so since 64 equals NPQ, I can write 64 equals 192 into Q. So, Q will be equal to 64 by 192. So, that will come up to 0.33. Q equals 0.33. Now, P will be equal to 1 minus Q, that is 1 minus 0.33, that is 0.67. So, P equals 0.67. Now, next I have to find, I found P, I found Q, I have to find N. So, N will be equal to So we are given here mean equals n into p equals 192. Then they have also given the standard deviation equals 8, that is equal to root of npq. So standard deviation the whole square will be 8 square, that is 64 equals npq. Now 64 equals 192q. So q will be equal to 64 by 192, that comes up to 0.33. So P equals 1 minus Q. So 1 minus 0.33, that is 0.67. Now NP equals 192. N will be equal to N into 0.67 equals 192. N equals 192 divided by 0.67, that is 286.56. Now the next problem. Obtain the binomial distribution for which mean equals 27, that is equal to mu or is equal to n into p, and variance equals standard deviation the whole square equals 9. So what will be the standard deviation? So we have here mean equals 27, that is mean equals n into p. So variance equals 9, that is npq equals 9. So npq equals 9 or npq equals 27 into q equals 9. So q will be equal to 9 by 27, that is 0.33. P equals 1 minus q, that is 1 minus 0.33, that is 0.67. So n into 0.67 equals 27. N equals 27 by 0.67, that is equal to 40. So we got the value of n equals 40, p equals 0.67, q equals 0.33. Now the binomial distribution will be p plus q whole to the power of n. So 0.67 plus 0.33 to the power of 40, that will be 1 to the power of 40, that is equal to 1. The next problem, in a binomial distribution, the mean is 6 and the variance is 1.5. Then find P of x equals 2, P of x is less than or equal to 2. So we have the mean. So we have the mean equals 6 equals NP, variance equals standard deviation the whole square, that is NPQ equals 1.5. So in other words, I can write 1.5 equals 6Q. So since n into p is 6, instead of writing NP, I write 6 here. So Q will be equal to 1.5 divided by 6. So this will be equal to 0.25 or P will be equal to 1 minus Q, that is 1 minus 0.25 is 0.75. Now, next will be, we have to find P of x equals 2. So, when P of x equals 2, we make use of the formula So in this problem, mean equals mu, that is 6 equals NP, variance equals standard deviation the whole square. So NPQ equals 1.5. So 1.5 equals 6Q, Q equals 0.25. So P will be equal to 0.75. P of x, that is probability of x equals 2, will be NCR into PR into q to the power of n minus r. So HC2 will be 0.75 the whole square, so 0.25 to the power 6. So 28 into 0.5625 into 0.00024, that will be 0.00378. So P of x less than or equal to 2, P of 0 equals P of 1 plus P of 2. So 8C0 into 0.75. So P will be equal to 0.75 to the power 0 and Q will be 0.25 to the power 8. So plus 8C1 will be 0.75 to the power 1, 0.25 to the power 7 plus 8C2 will be 0.75 the whole square, 0.25 to the power 6. So when we simplify this, we get the answer as 0.004161. Now the next one, 8 coins are tossed at a time 256 times. Find the expected frequencies of successes, getting ahead and tabulate the results thereof. So what is n? 256. What is small n? Equals 8. Now we have to find the expected frequencies. Now what is the formula? So we have here 8 coins are tossed at a time 256 times. Find the expected frequencies of success or failure. So we know that n is equal to, capital N is equal to 256. Then n is equal to 8. The number of trials is equal to 8. And the success is P is half, Q is also equal to half. Now the expected frequency is 0, 1, 2, 3, 4, 5, 6, 7, 8. So in the first case, the expected frequency of 0 head. So when 8 coins are tossed at a time, so the frequency of getting 0 head is, so we have to calculate using the formula n into nc or p to the power of r into q to the power of n minus r. So n is equal to 256, so 8CO, that is 8C0 into half to the power of 0 into half to the power of 1. So that will be 256 into 1 into 1, that is 1. Then probability of getting 1 head when 8 coins are tossed is again 256 into 8C1. So when we calculate the value of 8C1, it comes up to 8. Then half to the power of 1 is half, and half 1 by 2 to the power of 7 will be 1 by 128, that is equal to 8. Then the same way we keep on increasing the value of r here. So 256 into 8C2, that is half to the power 2, half to the power 6, that is 256 into 28 into 1 by 4 into 1 by 64, that is equal to 28. Then 256 equals 8C3, that is 1 by 2 the whole cube, 1 by 2 to the power 5. So this will come up to 56. Then p to the power 4 will be, probability of 4 heads is 70, 5 heads is 56, probability of 6 heads will be 28, probability of 7 heads is 8, probability of 8 heads is 1. So this is how you have to cast this binomial distribution. So if you can see the expected frequencies here, so what will be when it is P of 0, what is the probability of getting 0 heads? Only 1. Then the probability of getting 1 head is 8. The probability of getting 2 heads is 28. Probability of getting 3 heads is 56. The probability of getting 4 heads is 70. Probability of getting 5 heads will be again 56. 6 heads will be 28. 7 heads will be 8. 8 heads will be 1. So the probability will be again, it will just go up and come down. So if you can see this, the normal distribution curve appears like this. So 1, 8, 26, 56, so up to 70. Then again it falls down to 56, 28, 8 and 1. Now the next problem, a box contains 100 mangoes, 20 of which are defective. So 20 of which are defective, 10 are selected for inspection. Indicate what is the probability that all 10 are defective. So we have to see there are boxes, number of mangoes equals 100. So, defective pieces, how many are defective? 20. So, what will be P here? P will be out of 100, 20 is defective. So, 20 divided by 100. So, that will be equal to 0.20. So we have here a box contains 100 mangoes, 20 of which are defective, 10 are selected for inspection. Indicate what is the probability that all 10 are defective. So first we write number of mangoes is 100, defective pieces are 20. So P will be equal to 20 by 100, that is 0.2, or P equals 0.2, Q will be equal to 1 minus 0.2, that is 0.8. So all 10 are defective means NCR equals P to the power of R into Q to the power of N minus R. So 10C10 equals 0.2 to the power of 10 into 0.8 to the power 0. So it comes up to 0.000024. All 10 are good. So 10C10, that will be 0.2 to the power 0, 0.8 to the power 10. So that is 1073. Then at least one is defective. So we just minus this from the previous probability. So this will be equal to 10C10 equals 0.2 to the power 0, 0.8 to the power 10. So that will be 0.8926. So 1 minus 0.1073, that will be 8926. Then at most 3 are defective. So P of 0, P of 1, P of 2 plus P of 3. So when we just keep on adding the R here for the first probability, and we keep on reducing the Q for the next probability. So I get 0.1073 plus 0.2684 plus 0.3018 plus 0.101699. So the answer is 0.8384. So with this, we come to the end of this session. Hope you have all followed. Thank you.